So our webinar today from, like I said, one of our NCBC exhibitors, buildpulse. Our presenter today is Andy Marsh. Andy has 30 years of diversified experience with automated building systems and subsystems, including expertise in the energy sector. He's an SME for submetering, demand response, automated fault detection, diagnostics, and before joining buildpulse, Andy had global roles with Schneider Electric and more lately Blue Pillar. I'm going to turn this over to Andy now so we can get right into it. Thanks everyone for joining us, and I will be back with questions at the end.
Hello everybody, I'm Andy. I'll try and talk a little slowly throughout this. I've got a number of slides to go through, and as indicated, we do want to try and save a bit of time at the end to address any questions you might have. So I want to talk to you today about how you can use automated software to drive some recurring revenues. And basically, we see the market changing a little bit to address some real problems in the marketplace. As we hear every single day, people are being asked to do a lot more with a lot less. And to make matters worse, there is a lot of experience in the marketplace starting to retire, and they're not frankly being replaced. You know, the old trade schools that we all went through a number of years ago, really not happening too much these days. They are coming back, but it's not there. So typically within a building, you know, they're challenged with occupant comfort issues, ever complex building systems as new technology comes onto the market. As mentioned, there's a very much of a shortage of personnel and the kind of training that they go through, and they're always being challenged to reduce their budgets. And there's always a big challenge is how do I justify, you know, what I want to repair next? And a part of this webinar, we'll start to see a bit more about that. So how does this work? Well, there's two elements of this. It's really a software platform combined with managed services, which is where you come in. So we provide a cloud-based fault detection and diagnostics platform, which then in turn can be used to drive, as I said, this managed service. And that takes over sort of the energy management or the building energy management expertise that typically you might find on site, which no longer is available. Now that's often true in small to medium commercial buildings, obviously schools. They just don't have the kind of technical resource they need to be able to actually optimize their building's performance in near or real time. And again, that's where you guys come in. So the platform, the combination of the platform, the software and eyes on, your experience provides prioritized asset optimization recommendations, can provide expert guidance about what to do next. So it's like almost like they're employing a part-time energy manager. And they're based on statistical analysis, expert review, which you do, performance trending diagnostics. So very much a combination offer, which if you get the pricing right is absolutely recurring year upon year upon year, which drives your company valuations up 9 or 10x. It's amazing what a difference that makes. So what does it do? It actually looks at complete systems within the facility and individual equipment or subsystems of those systems, looking for opportunities for energy savings. I know over on the right you can see some examples of the typical things you might find. Our software doesn't just log what's going on, but it's also looking at things like short cycling, which for boilers and the like and pumps is a big issue. And as we all know, the number of leaking valves, failed damper, economizer dampers is huge. I'll give you an example. I spent a lot of money on bringing a plant that I had no access to my desktop many years ago, primarily because we were paying a lot of money for chilled water in the middle of the winter. Now this is in Indianapolis, Indiana. We don't get warm winters, and we found that all the valve actuators have been removed and the stems pulled down to keep them open 100% of the time. Well, I saved the cost in getting that system upgraded within just a matter of a few weeks once we replaced the valves. And then when we got to the shoulder periods, noticed that the economizers were failed. I saved the cost again during the next quarter. It's amazing what having remote access using systems like this can actually bring to your offering. So typical architecture we're looking at here, the network appliance can plug into pretty much any building management system. Doesn't have to be new, doesn't have to be LON, doesn't have to be BACnet. Doesn't have to be Ethernet enabled. It can be legacy, whereby we actually have to plug these things into a serial port on the older types of controllers. And it's very much plug and play, and it's outbound only. So we've never yet been denied access to a facility's network. Shouldn't say never, because never said, yeah, it could happen, especially on the federal market, of course. It plugs right in. We've got our own drivers on board that thing, so we don't have to rely on JCs or conversions. We don't ever have to do a BMS upgrade to get data out, which means you can walk in and offer this service at an incredibly low cost from an onboarding perspective to your customer base. So that can be used in a couple of ways. Obviously, continuous commissioning is huge, but also getting that data out for simple one-time trend analysis becomes very, very cost effective as well. It's plug and play. Typically 1 or 2 hours. We've actually got many, many end clients that actually do the work themselves. The network appliance is wired or wireless. So if you've got a decent wireless system within the building, that's all we need. Just plug it into the power. If it's an Ethernet powered system, plug it into the local Ethernet port. The appliance can be whitelisted, so the appliance can be tied down to a specific number of IP addresses, and the rest can be blacklisted by IT. It's very, very secure. We then take data out of these systems for a couple of weeks typically. We auto discover, and we use machine learning and pattern recognition to actually assign plain English names to any of those BMS points from any different manufacturer. Very rarely do we get involved more than just a few hours at the end of this process. And we pull the data one data point at a time, so we never affect the operation of the systems, whether it's old or a legacy system. And we typically pull all of the data every 5 minutes. Now, just an example, a couple of example screens now in terms of what you might typically see. And it's important that we present these things and prioritize them based upon the potential for saving money and energy. So this screen here is actually, we've bundled these by the equipment type. So as you can see on the left-hand side, air handling units or a dual deck system or a boiler system. And at the top, the first cost, the sunk cost. So since we started to detect issues related to the performance of that particular operating group, here's the approximate cost that we've seen wasted. And over on the right-hand side, should you enact the savings that we'll look at in a little bit, then within the next 3 months, you're projected to save between $57,000 and $69,000. And again, this is on a very large complex with a great many air handling units. And then we break them down by particular issues. In this particular case, we're looking at an uncalibrated outside air sensor, which is more than likely triggering an early startup, for instance, of the chillers, or it could be affecting the way the economizers work. So we prioritize individual system issues by cost and by the savings that can be attained from fixing those things. And we typically respond to our clients and suggest that they try and fix 3 or 4 of these a week or even a month. And we've got several clients, we'll look at a couple of quick case studies shortly, whereby now they've had the systems over a year, a couple of large universities, and we see very few high cost faults now in the system. They've been out and repaired them all over the previous year. Comfort conditions, our charts are, the data points on the charts are only shown relevant to the faults that we're showing, as you can see at the bottom here. We're basically saying the cooling coil can't satisfy the cooling load. And over on the next part of the steps, we're actually suggesting what it would take to go and fix that. So what do you need to do to go and take a look and repair this, this particular issue? And it justifies the PMs. It monitors all the equipment in real time. Well, near real time, because it's only bringing the data in every 5 minutes. And it can be used to optimize the runtime in the cycles. So an example, we've got a client in London. They were doing a nighttime purge because the inside of the building, it's a 350-year-old building, was getting quite warm, to say the least. So they're starting the air handling up at 4 o'clock in the morning, but our system quickly detected the economizer had failed. So the actual unit was dragging warm air out of the space and simply recirculating it. And it wasn't until 6 a.m. in the morning when the mechanical cooling system kicked in did the supply air temperature actually fall. So because we found this one night, and every night they're on out, we let the client know, and they actually changed, in the short term, they changed their startup schedule to match the mechanical cooling to avoid running the system for 3 hours as a recirculating unit. And that's just an example of some of the kind of things you might be able to find with this. Runtimes. Runtimes is huge. A lot of our clients either have stuff in hand, or the building management system, for instance, has not properly distributed the time schedules. And we find equipment actually running out of hours. And this particular report here shows you on every single building within a particular campus the average running times. So for instance, plus 20 hours, for instance, on the Hemmingson Center you see in the middle, there's about 17 pieces of equipment on that building running above 20 hours a day. And in the past week, it's increased by 5. So something's changing, and clicking on the equipment index in the middle will take you through to a very detailed chart for that particular building where it'll list every single piece of equipment running. Zone comforts. So I'm sure as many of you have witnessed over the times that there's always issues related to how warm or how cold particular zones are. And this is a very easy way for you to let your client know where those zones are and how often they're hot or they're cold. So this particular one is showing you here, it's an unfortunate example, but it's a generator switch room. 73% of the time it's warm, and it's warm compared to the set point within the schedule. So the idea here is a very easy way of showing the warmest or the coolest systems across the entire campus. And this can be used over time to either change the set points, because you might be wasting your time with the generator switch room, for instance, or there's a mechanical defect causing that problem. Either way, there's things that can be changed and energy savings to be garnered. So some features of the system. I'm not going to read this out. You can all read, but you are looking for issues related to the way the system is operated. And then on a monthly basis or a quarterly basis, which is quite often what we see, you can turn this reporting into a written document that goes to your client and suggest what can be done this quarter or this month to drive energy savings within that facility. So it's a great way of increasing your stickiness with your clients, because now you're not having to drive to site, you're not putting data loggers on site, which are only temporary. These things are running 24 hours a day, and for the life of the project, data is being stored for every single data point that we're logging. So that's always there, and the data is available to you at any time, either on the CSV export, or it's at the end of the project, we can just turn it off, delete it, and give you a hard copy or soft copy. So typically what we've seen on these things is we can reduce the energy spend by at least 10%, often higher than 20%. But that's only, of course, if the client actions something that they're seeing. So all the reports that we have are actionable. We tell them what the problem is, what the suggested outcome should be, or how to go about addressing the problem, and how much you can expect to save over the next 3 months. It's fully automated, fault detection. There is nothing for you to do. So there are some systems in the market right now which do take some serious training and setup time. Everything's done for you. The only thing you have to do is plug in that network appliance. We do everything else. And I've got a slide in a little while that goes through the pricing, so you can see what that looks like. Detailed, actionable reports and graphs. Reports and graphs without any real meaning are pointless, so we set about fixing that when we first started. You can improve the workforce efficiency. I've got a couple of use cases coming up next which demonstrate this. There are sometimes utility incentives available. Not much, because oftentimes, frankly, the paybacks on these are way less than a year. We typically see 3 or 4 times payback in a year. And once they fix the fault, steady 2x for continuous commissioning. There's always a positive ROI. And if a system like this isn't suitable once it's deployed, then within 30 days we can cancel the project, and it's a full money back guarantee. We're the only ones on the market that offer this. And it increases the portfolio value because the operating efficiency for the building, it has increased, has improved. So I want to quickly show you a couple of use cases here. Gonzaga, they had tried out 1 or 2 systems, and let's just say the implementation time from the competition was 6 or more months. We did 18 buildings in 3 weeks, and again, that's because we use a very automated processing of the data when it comes in, which takes just 3 or 4 hours of our time. Once the data has been processed, the naming conventions have been normalized, and we've got a couple of weeks work, a couple of weeks data. That's when we step in to give it a cursory review, and 9 times out of 10, there's absolutely nothing for us to do. We can even do systems that don't have data points assigned to them. So Gonzaga wanted a tool to empower their team. They also spent an inordinate amount of time checking set points across the campus. That was one of the key points that they wanted out of this system. So we deployed, like I say, 18 buildings, 2 million square foot in about a 3-week time period. And they have been reporting at least a 50% reduction in the troubleshooting they were doing. Primarily because what they were doing was just literally checking everything on a particular building, and then rolling to the next, and the next, and the next, and the next year they start all over again. And what they found now, they can actually prioritize and target those problem systems as they occur. And in the first 3 months, identified $100,000 in savings. And the cost here was something like $15,000 or $18,000 all in. That includes the setup. So they're very, very happy where this project deployed, and indeed we're increasing the size of the system at Gonzaga right now. Now this one was completely different. They had been really, really powerful at what they were doing for years on optimizing their building performance, primarily because they had a deal. Every penny saved went into a reinvestment in the team, whether it was technology or additional manpower or additional metering and so on, so they could really see what was going on. And they had an expert who was about to retire. I think we'll lose that experience. So they looked at technology as a way to replace that guy who had the 20 years experience on site. And that's partly what people in the market are starting to look for now. As the base of skilled resources is retiring, they are going to be replaced by systems can make actionable reporting and decision making. So this project here was a little bit smaller in terms of the number of buildings, but an increase in the square footage. It only took 2 weeks in this particular case to get it up and running. Now these guys, if you remember, had been very, very proactive. We were pulling out something like 150,000 data points, and yet we still managed to help them save 25% in terms of their troubleshooting time. And these guys, even though they've been heavily working on optimizing their buildings, we still managed to find things their own experts couldn't find, and found $80,000 in savings during the first quarter after deployment. And again, this is another client here that is expanding their scope right now. Now you're probably thinking this is horribly expensive, because that was one of the issues in the market a few years ago, and our founder set to break that. And I indeed witnessed this as a SME at Schneider. The setup time on these systems was inordinately complex. We needed copies of the points list, we needed copies of the mechanical drawings, we needed somebody to diagnose and determine what the point names actually meant. Well, we set about fixing all of that, and the price point reflects on this. So we typically start at about 3 cents a square foot for a one-off small building. But I'm recently pricing things up about 1 to 1.5 cents a square foot, depending on the size of the buildings, of course. We don't care how much equipment is in those buildings. So again, you can go into a large building with very few points, or a large building and it's stacked full of equipment, like a hospital might be. We don't care. It's all going to be priced the same way. Now, where you come in, we often find our partners are leveraging our services and adding 2 to 10 cents a square foot per year in managed services by using our platform as the key to get BMS data out, and using the reporting system that comes with it to actually drive the decision-making process, which you can report back into your client. Of course, there's a few factors that could impact the partner services. What's the cost of local energy, for instance? Obviously, the higher the cost, the more the ROI, and so on and so forth. There could also be some subsidies, not always, but there are some utility companies now are offering subsidies or incentives to go and deploy these things, especially on the West Coast, because they're looking at continuous commissioning as being a real thing, instead of the once every 4 years type of deal, which often happens right now. And then, of course, how much hand-holding does the customer need? So we've found a 3 types, really. Self-service, well, that's not somewhere typically our partners get involved. Somewhere in between, or a full service, which is where you guys definitely come in to provide the reporting that our clients need, your clients need, to make the right decisions to optimize how their buildings are performing. And when their buildings are performing well, that generally means that the people within those buildings are also performing well because the comfort conditions are being met. So with that said, I've actually ripped through these a little bit too quickly, but it does give us plenty of time for Q&A at the end. And I'm going to put this slide up here. I'm going to leave it up here for a while we take some Q&A. But you can join us with Bryce. He's our CEO, and you can take a much deeper look at the conference in November. And you can see my contact details down the bottom right-hand side. So, do we have any questions?
Sorry, Andy, I had a little trouble hitting my unmute button. I don't have, I have someone trying to send me something that looks like it. They keep typing and untyping. Let's see, Bruce, are you having trouble putting anything? I see your hand is raised. Did you have a question?
Oh, I just wanted to point out that the conference is in October, not November.
Oh, there you go.
Well, thank you.
So the next question that came in is, how does pricing scale for multiple building portfolios?
Okay, so that is a good question. Obviously, the more square footage you've got, the better we can be in terms of the pricing. So typically, for instance, we've got a deal right now to try and get you to bring us a portfolio, and we could start at up to 8 buildings, 1.5 million square feet for $15,000 annual and $5,000 setup fee. And from there on out, any additional buildings will be priced, get this, at less than ½ cent per square foot setup and 1.8 cents a square foot for the service fee. We can get more aggressive. It really depends on the size of the portfolio. Hopefully that answered your question.
Okay. The next question is, do you tie into any CMMS systems?
Not as a rule. We can, and we do have a preset sort of price to build those integrations, but not as a rule. So what we didn't show you today, because we really didn't have the time, is we have a rudimentary system like that built in, such that you can report both issues related to the point mapping or the fault analysis to us, or you can use it to say, okay, I've got this fault, I'm going to fix it next week. And it's the way our system tracks that either a fault has been repaired or that you plan to repair this thing. So to answer your question, no, not as a rule.
Okay, next question. Do you tie in directly to energy or utility meters?
So utility, no. We don't have green button or anything like that. Typically, sub-meters on a site, as we all probably know, are traditionally Modbus, and we use both Modbus RTU and TCP to tie into sub-meters that are on site. So when we show a demand chart, in our parlance, that basically means how many pieces of equipment are running throughout 24 hours a day, and we all know what an energy trend, demand chart looks like. If we have a meter for that same building, then we overlay that on top of our equipment demand chart.
Okay, any other questions? I don't see any coming in from the audience. Okay, with that, we will end today. I want to thank Andy. We really appreciate your time and expertise, and thanks to all of you who participated in this webinar. It has been recorded. It will go up on the BCA's YouTube station. We'll send that link out to all of you, so if you want to review it again, you will have that ability to. And as Andy pointed out, we will go into a little further depth on this at NCBC in October in Salt Lake City, and we'd love to see you there. Thanks, everyone.
Thanks, everybody.